बिस्मिल्लाहिर्रहमानिर्रहीम। आज का हमारा टॉपिक है इंट्रोडक्शन रिव्यू ऑफ सिग्नल एंड सिस्टम। व्हाट इज अ सिग्नल? अ सिग्नल इज अ पैटर्न ऑफ variation of some form. Signals are variables that carry information. Example of signal include electrical signal, voltage and currents in a circuit, acoustic signal, pressure signals, pressure over time, mechanical signal, velocity of a car over time, video signal, intensity level of pixel, camera video over time. How a signal is represented? Mathematically, signals are represented as a function of one or more independent variables. For instance, a black and white video signal intensity is dependent on xy coordinates and time t. So f of t is equal to xy t. Diagram is shown in the figure with respect to time t. Signal properties. In this course, we shall be particularly interested in signals with certain properties. Periodic signal. Signal is periodic if it repeats itself after a fixed time period, that is t. X of t, x t plus t for all a sin t is a periodic signal. Even and odd signal. A signal is even if x of minus t is equal to x of t, that is it can be reflected in the axis at 0. A signal is odd if x of minus t is equal to minus x of t. Examples are cos t and sin t signals respectively. Exponential and sinusoidal signal. A signal is real exponential if it can be represented as x of t is equal to c e raised power at. A signal is complex exponential if it can be represented in the same form, but c and a are complex numbers. Step and pulse signal. A pulse signal is one which is nearly completely zero apart from the short spike. A step signal is zero up to a certain time and then a constant value of t. Step and pulse signals are discrete signals, while exponential and sinusoidal even odd signals are continuous signals. What is a system? System process input signals to produce output signal. For example, a circuit involving a capacitor can be viewed as a system that transforms the source voltage to the voltage signal across the capacitor. A CD player takes the signal on the CD and transforms it into a signal sent to the loudspeaker. A communication system is generally composed of three subsystems: transmitter, channel, and the receiver. The channel typically attenuates and adds noise to the transmitter signal, which must be processed by the receiver. Another definition of system is a system is an aggregation or assemblage of objects united by some form of regular interaction or interdependence, a group of diverse units so combined by nature or art as to form an integral whole and to function, operate, or move in unison or often in obedience to some. A system is defined to be a collection of entities, for example, people or machines that act and interact together toward the accomplishment of some logical end. The state of a system is to be defined as an assemblage of variables necessary to describe a system at a particular instant of time with respect to objectives of the study. Example of systems are medical or biological systems, socioeconomic systems, communication and information system, planning system, solar system, environmental system, manufacturing system, management system, transportation system, physical systems, electrical, mechanical, thermal, hydraulic system, and combination of them. How a system is represented. A system takes a signal as an input and transforms into another signal. In a broad sense, a system can be represented as the ratio of output signal over the input signal. Properties of a system. Causal system. A system is causal if output at time only depends on input values up to that time. Linear system is linear if the output of the scaled sum of two input signal is equivalent to scaled sum of output. Time invariant system is if a system output is same given the same input signal regardless of the time. Attributes of a system. A system is characterized by the following attributes: system boundary, system components and their interaction environment. Can be classified on the basis of time frame, type of measurements taken, type of interaction, nature, type of components. According to time frame, discrete. A discrete system is one in which the state variables change instantaneously at separate points in time. For example, queuing system, bank telephone network, traffic lights, machine breakdowns, card games, and cricket match. Continuous. A continuous system is one in which the state variables change continuously with respect to time. For example, solar system, spread of populants, charging a battery. According to time frame, a hybrid system is a combination of continuous and discrete system. A hybrid system has the benefit of encompassing a larger class of system within its structure, allowing more flexibility in modeling continuous and discrete dynamic phenomena. For example, traffic along a road with traffic lights. Esoteric systems are the systems in which the measurements are not possible with physical measuring devices. The complexity of this system is of highest order.